Hello everyone and welcome to another MATLAB tutorial. This is an hour-plus video covering machine learning classification algorithms using MATLAB, and more specifically it covers the MATLAB toolbox, the statistic and machine learning toolbox. And just like in the previous MATLAB videos, Dr. Azam, who is the instructor for this course, has provided us with a limited number of free coupons. So if you would like to enroll in the 7-hour course, take a look in the description of this video and you'll see a link to enroll for free. There will also be a discounted coupon for I believe $10 if all the free coupons are out. And if you want a really good deal, you can head over to my website and get the complete MATLAB course bundle. And this includes several MATLAB courses covering everything from a beginner's kind of tutorial to MATLAB app designing, Excel interactions, and much more. So to all of you who are back enrolled in university and could use a hand with MATLAB, this is a perfect choice. You will get one-on-one help in the course, and at $19, it's pretty good value. So as I previously mentioned, keep an eye out for those free coupons. In the description to this video, I will include some timestamps as well so you can get a feel for the subject matter that's included in this YouTube video. If you liked the video, please leave a like. If you want to see more content like this, subscribe, and let's get started.
Before starting the course, I want to pump you guys about machine learning and its possible applications and its relevance to our real life. So let's look at some possible examples of machine learning. The first one is the text mining. It is used for finding interesting textual patterns that are present within the data, and it's frequently used in the applications such as text categorization, web filtering, email filtering, searching, and many others. The next application is the image processing. It is used in applications such as X-ray analysis, long nodule detection, satellite image analysis, and in industry for detecting faulty parts, and in medical image processing. The next application is the recommender system. It is frequently used by the online businesses such as the Netflix, Amazon, and many others in order to make recommendations to its users. The next application is the fraud detection. It is being used by the banks and law enforcing agencies in order to detect anomalies within the data. The next emergent field is the bioinformatics, which deals with the study of biological data and its processing on computer machines. It has applications in medicine, agriculture, and many other fields. So in this course, we will be looking at many machine learning algorithms that works at the back end of these applications. So hopefully you will enjoy this class and find your own ways to apply machine learning to deal with real-world problems and data. So see you in the class. Welcome to the machine learning course. This is Dr. Nouman Azam, and I am super excited to have you inside this class. In this lecture, we will be looking at the key essential advantages of MATLAB for implementing your machine learning algorithms. So let's look at some of these advantages. So the first thing you should note is that there are approximately 1 million users around the world who are MATLAB programmers or MATLAB users. And this creates a very rich online community and support, and they frequently contribute to the community in the form of codes, in the form of scripts, in the form of answers. The second thing I want to emphasize is that if you go to this website that is linkedin.com/closer-than-you-think, then it contains some useful statistics. So let me pull out that. So that's the first page that you are going to encounter when you open this website. And this website contains information regarding the current available jobs and the statistics about those jobs, that what are the different fields these jobs belongs to, and what are the essential tools that are currently being used within those particular job areas, and what are the skills that the employers are currently looking for. So that's what we want to emphasize, the skills. So if you pull out that, it will contain information regarding the different skills. And under the modeling category, you will find MATLAB as one of the key essential skills that the employers are currently looking for. The other essential advantage of MATLAB is that it provides access to different application-specific toolboxes such as bioinformatics, statistics, image processing, and many others. This means that you can take advantage of application-specific functions along with machine learning analysis under the very same platform. So for instance, if you are working in the image processing domain, you can implement different image processing techniques, and at the same time you can integrate and combine the results obtained with those techniques with machine learning analysis. This essentially leads to faster and easier implementation. The next advantage of using MATLAB is that you can create a beautiful ape out of your code, and you can convert your code into working products. For this purpose, the MATLAB provides you with the utilities called Guide and Ape Designer, which will lead to quick creation of GUIs. The next advantage is that MATLAB can be used to create auto-generate reports so that you can share the results of your analysis with your friends in the form of PDFs and LaTeX documents and so many other forms. Finally, there is a huge support for data visualization. The MATLAB provides you with different types of plotting functions, such as the bar charts, then the scatter plots, and so many other forms. I'm really looking forward to see you in the course. So see you in the course. Hello students, my name is Dr. Nouman Azam. I received my PhD from University of Regina. It is in Canada. I had over a decade of experience in research and teaching at the undergraduate and graduate levels. On the online learning platforms, I teach MATLAB-related courses on different online platforms such as the Udemy, the Skillshare, the Skillwise, StakeCommerce, StakeSkills, and many others. On the Udemy, you will notice my courses. They are listed on the very first page in the MATLAB niche. And so this is my course. This is the best-selling course. Similarly, this is another course, and this is also my course. With regards to research, I have investigated the use of machine learning algorithms in different applications such as text summarization, protein function classification, which is a subdomain of bioinformatics, topic modeling, which is a subdomain of text mining, similarly recommender systems, malware analysis, which is a subdomain of security, medical decision making, similarly spam email filtering, and many others. I'm really looking forward to see you in the course. So see you in the course. Welcome to Machine Learning course, Supervised Machine Learning Algorithms using MATLAB. So this course essentially contains 12 different segments. So let's see what we have in each and every segment. In the first segment, we will be looking at the instructor and course introduction. In section 2, we will be quickly covering the MATLAB essentials, and those essentials will give you a quick start in order to get familiarized with MATLAB and start implementing your machine learning algorithms. In segment 3, we will be looking at from where we can get the data set and how we can import it into the MATLAB environment. From section 3 onwards, we will be looking at different machine learning algorithms. So in section 4, we will be looking at the first machine learning algorithm, that is k-nearest neighbor. In section 5, we will be looking at another algorithm that is called naive Bayes. In section 6, we will be looking at decision trees and its different variants. In section 7, we will be looking at another popular algorithm for classification, that is discriminant analysis. In segment 8, we will be looking at support vector machines. Similarly, in segment 9, we will be looking at error correcting output codes. In segment 10, we will be looking at how we can combine different classification algorithms and build a super classification algorithm, and this technique is called Ensembles. In section 11, we will be looking at how we can create different validation methods in order to evaluate our classification algorithm. And then in section 12, we will be looking at how we can actually evaluate the performance and compare to different classification algorithms. So that's it for this course. See you in the course. Hello students. So before starting the course, it will be quite useful if I introduce you to the MATLAB software itself and the online help that is available for this software. So you basically go in Google and you write MATLAB, and then the first website is the official website of the MATLAB. So the first thing that you may notice is its pricing. remember that it comes in 4 different types of pricing. So if we click here, we may know about it more. For example, the first one is the standard software. In most of the cases, you will not be needing it. It's $2,350 US. Then we have the educational software version of this MATLAB. It is around $550 US. Then we have a home version. It is around 85. And then there is a student version, which is around only 29 US. But remember that basically there are a lot of add-on products, which are essentially the toolboxes that the MATLAB provides. So if you add additional toolboxes, it will cost you $16 each. What kind of toolboxes are being available? So there are different kinds of toolboxes. For example, from the bioinformatics domain, from the image processing domain, and so many others. So you can always customize it. For example, we can see here the available add-on products list. Okay, so there are many. For example, we have ones from computational biology, from computational finance, control system, data science, image processing, machine learning, and so many others. And the good thing about is that you can always use the links that are being provided in order to browse what actually these toolboxes contains. For instance, if you know a lot about the bioinformatics domain, so you may browse a little bit what are the different facilities that are available to you using this toolbox. You may notice the functions, or you may look at the documentation, or some apps that are being provided to you. So these apps are essentially the already built-in programs that people have written for you, and you just use it. So that was about the pricing. The good thing is that in some institutes, they already have free versions for their students, so they buy it in bulk and then they give it free to the students. So check with your institute. If you are a student, they will definitely provide you with a free version of that. If that is not the case, then you can buy it for $29. Right. Okay. The next thing is about the community help. So we have a very large community for this software MATLAB, and here are some of the statistics that we have. These much contributors, and we have people ask questions, so there are 120 answers per day for each and every question. Okay, so and the other thing is that there are so many different headings over there. For example, if you are looking for some code, you may better look here at the file exchange. So in the file exchange, again, we have built in like the functions that the people develop, and then they contribute it over here, and then we have apps, examples, videos, and so many other stuff. So basically, when you do advanced programming in this MATLAB, so you may not be able to get the answers of each and every question directly, or there may be some specific scenario for which you are looking for an answer. So the best place to look for the answers of those specific problems is to search here. The other interesting place that you may visit on this website that may be of your interest is this support. So for instance, you can write anything over here. For example, I am interested in the definition of the mean function. So I will go to the support. So in support, again, we have so many different options. For instance, we may look at the answers, or the file exchange repository, or the examples. Additionally, we have a lot of videos that people try to contribute here. So basically, it is your best website if you are stuck with some very specific problem that you find difficult to find answer for. So that was a little introduction of the MATLAB software. See you in the course. Hello students, welcome again to the course. So in this lecture, we will be looking at the basic graphical user interface of the MATLAB. So let's go directly and start. So the first thing you may encounter is this command window. This is the window which is spanning majority of majority of the screen, and this is the place which we will be using more frequently within the entire course, and it is the place where we actually interact with the MATLAB software. What do we mean by that is that we are going to give certain inputs to the MATLAB software and then expect some processing that is done on our behalf by the MATLAB, and then we expect certain outputs, and that will become visible here on this command window. So we will be using it very frequently. For now, you may give it some meaningful calculations, right? So here you may think of it as a very big calculator, but of course it is beyond that, right? So it can do more operations than the simply calculator can perform. Okay, so some of the other windows that you may look at here is the workspace. So it is going to hold the results of our computations. That is, if we assign our computation to some variables, so it is going to hold that variables for us. Then there is another window that is called the current window. It is basically a dedicated folder which will store our scripts and programs that we want to run and we have saved using the MATLAB software. You can change this default dedicated folder, and you can do it from here, right? Remember that you cannot go up in the directory levels from here. Within this window, you can just browse within a certain directory that is specified by here. So in the MATLAB directory, there are these, this is the directory structure, right? We can further explore that. But you cannot go up in the directory. If you want to go up, you need to use this this small area, right? So you can go up and select an appropriate place where you want to store, or if you want to change your default directory. Then there are some tabs at the top. This is the home tab, where you may see some of the conventional options, such as you want to open certain script, right? So you can mention that, or if you want to work with a new script and so on. We will be covering some of them later on in the course, and they will become relevant as we progress along the course. For now, you can just familiarize yourself. This is the plotting option. So there are different plots available for plotting your data and visualizing them. Of course, there is another one which is called apes. So you may consider it just like an app store, which contains a lot of different apes. And only the apps that comes with the MATLAB distribution are going to appear over here. You can add and delete apps from here, right? And these apps corresponds to different fields such as math, statistics, control system, signal processing, image processing, and so on, right? So these are some of the popular apps from databases, from computational biology, and so on. For now, let us consider some more meaningful operations. So let's say we want to define certain variables. So all the operations we did so far, they were not being stored with us, right? So let us try to store them. So you can assign it to certain variables like this with an equality sign, and then it will be stored in this variable A. So when you press enter, you may note a sudden update here in the workspace, right? A equals to 8. So you can do some more operations. For instance, you can say B equals to variable A minus 4. Now the variable A value is going to be put over here, and then 4 will be subtracted from that. So you will notice another variable over here. So that's how this workspace is going to be updated. And you may also note that there is a default variable called ANS, right? So if something is not being stored into a variable and MATLAB performs some operation over here, so then it needs to store that, right? And if you don't mention any variable, it is going to be stored in the default variable, which is ANS, right? So if we do something like this, right? So now you notice that ANS has been assigned this value, right? So that's the default variable if you don't mention any variable name. So in the next few lectures, we will be looking at some more details, so stay tuned. In this segment, we will be looking at some more key information regarding the MATLAB and how the MATLAB is going to work. So in the last lecture, we have highlighted the use of variables. So for instance, we have declared some variables that is called a equals to 8 or a equals to 9 and b equals to 10 and so on. Right. So the first thing you note is that if you press the up arrow key, it is going to give you the result of all the commands that you have executed on the MATLAB command window, right? And it is also going to give you a timestamp for that, right? So if you close the MATLAB and restart the MATLAB, then there will be a new timestamp that will be added alongside with those commands. So if you come later on tomorrow and open the MATLAB again, so there will be a new timestamp. Or if you close the MATLAB and then reopens it, then again there will be a new timestamp. So it will tell you at which time you executed which of the commands, right? So it's quite helpful in order to keep track of all the commands that you have executed on the MATLAB software. The next important command that you should note is the whos. When you press enter, it is going to give you the information regarding all the variables that are currently being stored in the workspace, right? And some few statistics about that. For example, its size. Remember that each and every variable in MATLAB is going to be treated as a matrix. So if it is a single variable such as a equals to 9, then in that case it is a 1 cross 1 matrix, right? So this one stands for the rows and the second value stands for the columns. So 1 cross 1 means 1 row cross 1 column. We will be looking soon how we can define matrices of bigger sizes, right? But for now, you should note that each and every variable in MATLAB is treated as a MATLAB, and that from where it name comes from, that is the matrix laboratory. So the next thing you may note is that CLC command. So when you press this command, it is going to clear your screen and you will see nothing on your screen. So completely blank screen, right? Similarly, if you want to delete some of the variables from your workspace, so then you need to use the command clear and then variable name. So it will clear that variable from here, right? So we do not see any variable here with the name A now, right? And if you look at whos, so the A is not going to appear over here now, right? So it has been deleted from the workspace. Similarly, if you want to change the name of the variable, you can do it from here, right? You can edit its value. And moreover, if you want to save certain variable, so you can save it onto the memory, right? And it will be saved with the name .net, right? So let's save it here in the default directory. So then we will call it, let's say, give it some meaningful name. So let's say I give it a name, my variable. Right? So now it has been stored in the MATLAB directory and we can have a look at it here, right? That is the variable that I just saved. So if you want to load this variable, you just need to double click it and it will load it into the memory again. Please note that when we double click it, so then it is going to load under the same variable name on which we have saved that, right? So we saved it with the variable name B and then we change the name over here, but this name actually does not have any effect when we load it again, and it is going to be loaded within the same variable. So if you want to make sure that yes, it has been loaded correctly, you can clear all the variables and then double click it, and then you may note that it is going to be loaded under the same variable name that we have used it in order to save, right? So that's how it's going to work. So now let's look at some of the matrices and how we can define matrices within the MATLAB. So in order to define matrices, you need to use these square brackets, and then within the square brackets you can mention some values. So whenever we press a semicolon, so then it's expecting the second row of that matrix, and individual values within a matrix are going to be separated by a space. So now it will create a 3 cross 3 matrix. Please note that within the matrix, the number of columns must be the same, right? So the rows has not any restrictions, but the number of columns in each row, they must be the same. So if we define a matrix like this, it is going to throw an error message because the number of columns within this row are not matching the number of columns over here, right? So it is not allowed. So the number of columns must be the same. Now once we define this matrix, you can have access to a lot of different functions. And the first thing that you may note here is that the A has now been updated and it has all the metrics corresponding to it. So if you double click it, it will show you all the values corresponding to that matrix, right, in this form. Similarly, you can add more statistics over here. You can add the range, the mean, median, right? Similarly, the max, the standard deviation, the min, max, variance, standard deviation, and so on. And you can view that with those statistics for this particular matrix by scrolling down here. So it will show you the size, the variance across its different values, the minimum value within this matrix, which is 5. Similarly, the maximum value, that is 9, the standard deviation, the median, and so on. So please also note that since this was a 1x1 matrix, its min max will be the same value because it contains only one value. So 10 is the minimum as well as maximum. There is no standard deviation and the median is 10 as well. So these values are not very much meaningful when you have a 1x1 matrix. Rather, they become more meaningful when you have bigger sizes of the matrix. Now let's look at some more functions that you can perform on top of the matrix. So remember that we have access to the variance, the minimum, maximum, standard deviation, and so on. So suppose we have this matrix A, which we just defined. So if we want to have access to the minimums across the columns, right? So for that, you can use the function min A, right? And that will give you the minimum across different columns. So remember that this is the minimum of the entire matrix. And with this function, you can get the minimum across different columns. Similarly, if you want to have a look at the minimums across different rows, so in that case, you need to pass to this function minimum 3 arguments. One is the matrix for which you want to perform the row-wise minimums. And then you need to pass to it this empty matrix. This is the syntax of MATLAB. And then you need to say 2 over here. And then it will give you the minimums across the rows. So remember that this min A, this is essentially equivalent to min A, and when you mention 1 over here. So these two sentences are equivalent. When you press enter, it will give you the same result as this one. An alternate way of finding this minimum across the rows is to just take a transpose of the matrix A. So when we mention any matrix name and then followed by a single quote, it is going to take a transpose of that matrix. So you can verify that. Right? So now this A, this is the transpose of this matrix A, right? So 5, 8, 7, they become the first row over here. And then you can call the function min with the transpose of that, and then it will perform the row-wise, but it will show you the result in columns, right? So the result is not row-wise, but the result is row-wise, but actually you have visualization of that it is a columns min. Similarly, there is another function which is called the max. It will give you the column-wise maximum, right? And if you want to have a row-wise maximum, then you can use either the transpose or just use this syntax. Right? Okay, the next thing is the mean. So if you want to have a mean across different columns, you can mention that. And if you mention 2 over here, then it is going to give you the mean across the rows. And another way to get the mean across the rows is to take the transpose of that. It will have the same value, but it will just change the display style, right? So that's how it's going to work. If you want to get the mean of the entire matrix, so then you need to mention it twice. You need to first calculate the mean across the different columns and then take the mean of that, and then it will give you the global mean of all the matrix, which is 7.78 in this case. Similarly, if you want to have a minimum across the entire matrix, so then you need to use it twice, min A. It will give you the minimum of the entire table. Similarly, if you want to have a max of the entire matrix, you need to use it twice, max of A. It will give you the maximum value across all the entire matrix A. Similarly, there are other functions. There is the sort function, right? it is used for sorting the values of the matrix. So when you say sort A, it is going to sort these values. But remember that by default, it is going to sort across the columns, right? So these are in sorted order. If you look at A's, right? So this column was not sorted, but it has now sorted that column. So this column was also not sorted. If you want to sort them based on the rows, right? So you can mention that by adding an additional argument over here. Similarly, if you want to sort them based on not in ascending order, but rather in descending order, right? That is, the greatest value should appear over here. So then you can mention an additional argument over here, that is descent. Descend, right? So it is going to sort them now in descending order, right? Similarly, if you want to do it on the rows, right? So you can take transpose and then mention it over here, and it will do the job for you. An alternate way of sorting based on the rows is to just mention sort A and then mention the dimension across which you want to sort. So it will sort now based on the rows, right? But again, by default, it is going to do it in ascending order. If you want to mention it in descending order, so then you can mention that descend. And it will now sort by rows, but in descending order, right? So the greatest value is here and the least value is here across all the rows. So these were some of the common operations that you can perform on top of the matrix. Of course, there are a lot more details, but we only concentrate on those details which are relevant to this particular course. So hope you're enjoying the course. See you in the next segment. Hello students, welcome to the new segment of the course. So before going into the details of machine learning using MATLAB, it will be useful to look at some of the very basic stuff regarding machine learning. So the very first thing that you need to notice is the types of data that you may encounter that you want to analyze using machine learning algorithms. So the first data type that you may encounter is the numerical data. What do we mean by it is this, that the data is of some quantifiable nature, that is, we can measure them such as the height of the people, the age of the people, the salary of different employees, and so on. So again, we can categorize the numerical data into two parts. First one is the discrete types of data, where we are dealing mostly with integers, and it represents basically some counts of some phenomenon. For example, it will represent how many students liking a course, or how many visits that a particular website has been encountered, or some other quantifiable thing which we represent in terms of some integers. Similarly, the other category is the continuous category. Here, the possible values are infinite. There is large number of possibilities, such as how much water that you drink on daily basis. So it will be again in some fractions, or alternatively, you may say how much rain fall on Monday, right? So this will be a lot of fractions that are being involved. The second type of data that you may encounter is the categorical data. Here, it is not of quantitative nature, rather it is of qualitative nature. That is, it represents some qualitative type of data. The important thing is that it does not have any inherent mathematical meaning, such as we cannot say that it is greater or less than some phenomenon. Suppose some examples include the gender, the nationality, the product type. So it's basically describe different categories that are present in your data, based on which you can categorize and split your data into different pieces. Sometimes you may assign numeric values to the different values of these categorical data. For example, we may assign male equals to 1 and female equals to 1, and that is because of easiness in the processing. But remember that this 1 and 0 does not have any meaning attached to that. That is, we cannot say 1 is less than 0 in this case, or 1 is greater than 0 in this case, because It is not representing the numeric aspect of that. It is just for the sake of representation, and that is because our computers can only deal with numerical data. Finally, you may also encounter some data which is a mixture of both the categorical and numerical data types. In particular, we define a data to be ordinal if it is categorical data, but it has some meaning attached to it. Suppose the student grades, we may say that it is A or A minus or B, B plus, B minus, C plus, and so on. But we know that A plus is greater in grade as compared to B plus, right? So we have the corresponding meaning attached to those categorical data as well. The other example is the ratings that we give to the movies on different websites, which is on the scale from 1 to 5. But again, we notice that it has a mathematical meaning attached to that, right? So whenever we encounter such kind of data which has a categorical description but also has meaning attached to that, mathematical meaning attached to that, so we will call it that this type of data is the ordinal data. Finally, let's look at a very quick activity that whether we have what we have learned so far, we can apply it correctly or not. So I want you to identify from these following four different types of data, whether they are numerical, categorical, or ordinal. So let us look at the first data, which is the fuel price. We know that the fuel price is always in some amount of dollars, so it is numerical data. The humidity level on the scale of low, medium, and high. So it is a categorical data because it has a categorical description, but we may also look at that the medium is less than low, low is less than medium, and is less than high. So this means that the categorical data along with the mathematical intuition behind it, so it is ordinal data. Categorical description with mathematical intuition, right? So ordinal data. Similarly, we have marks obtained. So again, the marks obtained is on a scale from 0 to 100 in most of the cases. So it will be a numerical data. Finally, grades achieved, as we discussed earlier. Grades achieved are, in our country, the grades are like this, that A plus, A minus, B plus, and so on. So the grades achieved are categorical, but since it has a mathematical meaning attached to that, so it will be ordinal data. So fuel price, again, numerical. This one is ordinal, this one is numerical, and this one is ordinal again. Hope you are enjoying the course. See you in the next segment. Hello students, in this segment we will be looking at some of the popular places from where you can grab your data sets for using in your machine learning algorithms. So the first one in the list is this one, that is UCI Machine Learning Repository. So you will find a lot of papers over the internet related to machine learning that they are using this repository in their experimentation. So they have a very good listing of all those data sets. And they have actually classified it based on different characteristics of these data sets. For example, from life sciences, you can find out these. From classification tasks, you can find 29 of these, and so on. So if you want to view all of them, you can just click it over here, and it will represent. Okay, so that's quite a place that you will be looking at most of the times. Okay, so the other one is if you are interested in, this represents all the data sets, right? So we have around 360 data sets in the machine learning repository corresponding to different fields. And it gives you some statistics of those data sets as well. If you are interested in text categorization, so this is the famous data sets for that, Reuters 21578. Some of the publicly available places for machine learning data sets. This is the list of those 8 popular sites where you can find those. And finally, another interesting place is this one. This is for recommender systems. This is the movie land data sets and its different versions, so you can always download them and use it in your experimentation. So some of the other places that you may find the data sets are the particular research papers that you are reading, and in majority of the cases they will upload their data sets onto the web. So you can download it from there if your field is not listed over here. So those were some additional places that you may search out for. Okay, so in the next few segments we will be looking at how to import these data sets into MATLAB. So stay tuned. Hello students, welcome again to the new segment. In this segment, we will be looking at the very first step in analyzing and building your machine learning algorithms using MATLAB. And that first step is to grab your data and then transfer it into the MATLAB environment. So let's look at some example. Remember that we have a lot of data available over the internet. And a very useful place for browsing a different kind of machine learning data that is available for experimentation is to go to the machine learning repository. It's an online repository that contains different kinds of data sets corresponding to different machine learning problems. I will use the very frequently used data set, that is the RS data set. So when you click on this data set, a lot of information regarding this data set will appear, such as the number of instances it contains, the data set characteristics, the number of attributes, and so on. So when we go to the data folder of this particular data set, there is a file that is the .data file, and it contains actually all the data corresponding to this data set. Right, so we can actually copy this data set and make a copy of it and store it somewhere on our system. Right? And then we can read it into the MATLAB environment. So we can just copy it, select it, copy it, and then paste it into an Excel sheet, and then save it with appropriate extension so that we can read it into the MATLAB environment. So I have stored it in two types. Right. One is the CSV file, which contains the same data as the data that is present over here. The CSV stands for comma separated version, right? And in this case, since all the data has been separated by a comma, right? So that's why I saved it in a CSV file. Alternatively, when you open the same data in Excel, you can save it in XLS format or XLSX format, and so many different formats that you can save it. When your data is in some other format and not in these formats, then there is another procedure for reading that in the MATLAB environment, and we will cover that as well. So don't worry about that. Okay, so once we have the data, the preferred data type or the preferred way of transferring it into the MATLAB environment so that it's become very easy to manipulate using the machine learning algorithms is that of a table data type. Remember that we have simple data types such as the numeric data type or character data type or so many others. But the essential difference between those data type and a table data type is that the table data type can contain data in various formats, right? So such as numeric, floats, integers, characters, strings, and so many others. That's the essential difference. So in order to read that data, we need to use the built-in function that is read table, and then we need to mention the path where our data is stored. And that path needs to be enclosed in these brackets, right? And then we need to mention the path. So my path is C, and the file name is 1, and the extension is CSV, and then we need to assign it into some meaningful variable. So let's say it's T in this case. So when we press enter, now we may notice that something has appeared over here. That means that our T variable, which is a table data type, has now been updated and it's available for manipulation. And it contains 150 rows and 5 columns. So if you want to have a look at some of the data, you can do that with the help of a colon operator. The colon operator is very useful in MATLAB. And with the colon operator, we need to specify an initial and final position. So if we mention it from 1 to 5, it will mean generate numbers from 1 to 5. And when we mention it inside the table environment, so it will mean that please, we are working with the first 5 rows, right, from 1 to 5. And then after comma, we are selecting the columns. So in this case, I am just mentioning the column without the initial and the final point, which means that display all the corresponding columns. So now when we press enter, it is going to display the first 5 rows corresponding to all columns, right? And that is our data here. Please note that the variable names var1, var2, var3, var4, var5, since our data does not contain the variable names, so it is going to give it a default name, variable var1, var2, var3, var4, var5. If we want to change that, you can do that with the help of the properties of the table. And we can mention variable names. And then you can give new variable names to the variables that you want to have to appear over here. And we can enclose it in quotes, and we can say sepal length. Remember that the variable names should not contain any spaces. And then we can say sepal width. And then we can say petal length. And then finally petal width. And you can say that the final variable in this case is the response variable, so we call it a class. When we press enter, it is going now to update our variable names. So if we display it again, we now see that the variable names have been changed and they look a little bit more meaningful now. We can also have a look at some of the statistics of this table. And it's going to display some of these statistics for the different variables. That is the minimum value for this sepal length. It is 4.3, the median is 5.8, and the maximum is 7.9. Similarly, some other statistics of the other variables. For the last variable, it does not display any mathematical statistics since it is not a numeric variable, rather it is a different data type, right? So that's why it's not displaying any particular statistic for that. The other way around is to use the import data tool. And with this import data tool, you need to mention the place of the file where it has been located. So you need to browse it. So let's say this is my file. So I will select it. So once I select it, another window is going to appear and that will contain our data, right? So in this case, this is called the import tool and it contains all of our data. So by default, it is going to give it the default variable names. You can redefine them and you can give them meaningful names such as sepal length and so on, right? But for now, I just keep the default names. And then automatically it is going to learn its type, right? So it is saying that the last variable is of type text and the rest of the variables are numeric. So once you select the data, you can select it by pressing the control button and then clicking on the corresponding columns that you want to import into the MATLAB environment. And then you need to click this right button and then it will read all the data into the MATLAB environment. Right? So we have all the data in the MATLAB. And now you can create a table out of that. So we call it T1 and you can say table var1, just mention the variable names, var2, all the variables that are appearing over here, similarly var3, var4, var5. Now it will create a table and all the data has now been read into the table T1. If you want to have a look at some of the instances, or just say T1. So it contains all the data that we have just imported. So you can use either of the methods, either use a read table function or use the import tool in order to import the data into the MATLAB environment. And once the data has been imported, then we are ready to apply some machine learning algorithms on top of that. So in the next two lectures, we are going to cover more. Hello students, welcome again to the new segment. In this segment, we will be looking at some more information regarding the table. Remember that the table data type is very frequently going to be used within our course. So that's why I've created this lecture in order to elaborate a little bit more on the table data type. So in the last lecture, we have seen how we can read the table, how we can grab the data from the internet and then read it into some variable, right? So we have read it into the variable t, which is of type table. So the first thing that we may want to do is that we may want to select certain rows from this table. So we can use the colon operator, and then with the colon operator, you can actually do a lot of different selections, right? So in this case, I want to select the alternate rows. That is, I want to select row number 1, and then row number 3, and then row number 5, and so on. So if I want to do that, I need to mention an additional argument over here, and an initial point, and then the ending point. So these two are representing the initial point and then the ending point. That is, start from row number 1, and then skip alternate rows, and then go up to the end. So it will select the alternate rows. That is row number 1, then row number 3, then row number 5, and so on. So if we display certain instances of this, so you may note this. So let's display t as well. So let us look at it. So this was the result of t, right? So in t, we may look at that the first row contains 2.5, and then the second row 4.9, and the third row 4.7. So it will skip the row having value of 4.93 and so on. It will select 2.5 and 4.7, right? 2.5, 4.7. So 4.9 row has been skipped over here. Similarly, you can select different columns. If you are not interested in all the columns, you can mention that please give me only the column number 5, right? So which represents the class names and represent all the corresponding rows. So this way you can grab the class labels. And of course, you can assign it to some variable C, let's say class names, and then you can say T, just give me the final variable, or we can say end, right? So that will assign to this variable class names all of the names of the classes. Similarly, I can select rows from the end, and then I can mention a step size, let's say -3, and then up to 1. So what essentially it's going to do in this case is that it will go from the end, so it will pick the ending row, and then it will skip 3 rows, right? And then it will select another row, and so on, and up till it comes to the ending point, that is the row number 1. And it is selecting all the columns. So that's how we can select different columns and different rows in different ways, right? And if I mention only 1 to, let's say 5, so then in this case, I have skipped the step size, right? So I'm not mentioning anything in between. So by default, it is going to give the step size equals to 1. That is, if we don't mention anything in between 1 and 5, so then in this case, it is going to consider it as 1. That is, take out each and every row starting from 1 up to 5. So it would select the 5 rows. Similarly, I want to select row number 1 to 5, but only corresponding to column number 1 to column number 3. So then I can mention it like this. So that's how you can do some selection on top of the rows and top of the columns. Now the next thing is that suppose we want to change the order of the columns for just the sake of display. So how we can do that? Well, you can use the square brackets, and then you can mention the variable that you want to display at the position number 1. So I want to display the classes, right? So the classes is the column number for the classes is 5. So I will mention it as the first argument over here, which means that on column number 1 display the values of column number 5, and for the rest of them I just keep it the order, right? So the column number 2 will be our column number 1, and column number 3 will be our column number 2, and so on. So now when I press enter, it's going to display the class names first, and so on. So similarly, if you want to display the columns, the class names as your second column, so then you can mention it like this, right? Similarly, you can change the order of the rows, as well, right? But it's not very meaningful if we change the order of the rows. The next important thing that you may want to do is you may want to sort the rows. So by default, it is going to sort based on the first variable within the variable t, right? So our t is the table data structure. So the first column in that table data structure, it is going to use that in order to sort. And by default, it is going to sort in ascending order. So if you have a look at the result, so now it has sorted all the values based on the first variable. If you want to sort based on a particular variable, you can do that. And you can mention an additional argument over here that I want to sort, but I want to sort based on variable 2. Right? So when you press enter, it is going to sort now based on the variable called variable 2. Right? And additionally, if you want to sort in descending order, you can mention that as an additional argument, and now it is going to sort in descending order based on variable 2. Right? So we noted that the least value is the last value now, and it is in ascending order from the end, but in descending order from the top. Right? So the highest value in this column is 4.4, and then it is going in descending order. So that's how you can mention that. In case there are some ties, right? So we may note that now here there are some ties, 2.6, 2.6, and 2.5, 2.5, 2.5, and so on. So in such a case, if you want to have a look at another variable, that in case of a tie, please look to another variable, and that variable is, let's say, variable 3. So you can mention an additional criteria for that. And you can say that when there is a tie, and when you present all the variables in descending order, and when there is a tie on this variable, so then for variable 3, make them in ascending order. So you can mention something like that. And now it will represent the results in this order, right? So now if you look at the results, so there was a tie, right? 3.6, 3.6, 3.6, and then based on this tie, we look at this variable, and now here the results are being in ascending order. Similarly, there was another tie over here, and when there is a tie, it conserves variable 3, and then it makes an order that we mentioned over here. Similarly, you can mention as many criteria as you want, and that will be taken care of automatically. Finally, the read table data function, the read table function that we have used, we have seen that we have passed to it the CSV data type. If your data is in some other type, then you can also mention that. For instance, I have a data in txt format. So then I need to tell to this function that what kind of delimiter I am expecting over there. And then it will use that delimiter in order to read the data from there, right? And then you need to assign it into some variable. So let's do a quick example on that. Remember that we have created our data and we have saved it under the name 1.csv. So let's make a copy of that, or you can open it in the WordPad. And when you open it into the WordPad, you can copy this and make a new copy here, and then properly name it, let's say 1.txt. And when we open it, we can just paste it over here, and I will just try to replace the default delimiter over here, and I will replace it with, let's say, this symbol, right? And we can say replace all. So when we save it, now we are in a position to read it. And the delimiter here in this case was this, right? So when you press enter, it is going to read the same data for you, right? So this means that you can read data in any type. The only restriction is that you need to pass to it the proper delimiter, and by using that delimiter, it will read the data for you. So these were some of the more tricks and information regarding the table data structure. And of course, if you are more curious about the table data structure, you can consult my other course that is on, you can go to Udemy. And then search for the MATLAB. And then there you may find my second course, which is specifically on the MATLAB. And here I have a lot of contents on the table data structure. So here you may find that. So I have more than an hour of lecturing on the table data structure, the table data type. So if you are more curious about that, either take this course or you can consult the corresponding help. And you may find very useful topics in the help, right? So you can click on that, and then you will find a lot of different information regarding this, the syntax, examples, the input arguments that you may try, and some more examples. So that's it for now. Hope you're enjoying the course. See you in the next segment.